The figure shows MNOP is a square drawn on a grid table. Okay, MNOP with the side of length 1 unit means that here oh, the length here and the length here will be the same, which is equal to 1 unit. 1 unit. Q and R are the midpoint of MN. So the Q is the midpoint of MN and the R is the midpoint of OP. So we have three points here, X, Y, Z, which move inside this M and OP, inside this square. Okay, X is a moving point that's always equidistant from the side MP. Okay, where's MP here? MP and the side NO. Okay, so if you have straight line like this, NO, and you have another straight line, MP, equidistant from these two parallel lines, it will be like a meter here, right? So the distance here and the distance here will be the same. So the locus is here. By using the letter inside the figure, state the locus of X. So we don't have to draw, we just state the locus of X. Part A, the locus of X is the straight line QR. Okay, it's over here, QR. Okay, how about B? In the figures on draw, this one we need to construct a locus. The locus of point Y that's moving 5 units from point O. So this is point O. Constant distance from a fixed point. Then it will be a circle, right? But here we cannot draw a circle because the point Y only moves inside the square. First, take out your compasses. Constant distance from the point O. So the needles of the compasses placed on point O here. Okay, 5 units. You have to open up your compasses. 5 units. So 1, 2, 3, 4, 5. Okay, 5 units. Then just draw it out. 5 units. Okay, so this is the, I think the diagram, maybe just now I changed the size so it become not really accurate. You see here, this one should exactly 5 units. 1, 2, 3, 4, 5. It should be here, but it's go up a little bit. So this is the locus of point Y. So remember, after you draw a locus, label it. Okay, label it. Locus of point Y. Okay, now we go to this one. The locus of point Z, that's always equidistant from MN. Okay, NM is over here, and NO is over here, equidistant from two intersecting lines. So it will be the bisector of the angle, right? So this angle 90 degrees, we bisect it. Okay. Here you can use the compasses. If you don't want to use the compasses, also no problem. Why? Because this is a square, right? So when you connect this point, this diagonal will definitely bisect this angle O and M into 2 equal half. The diagonal. So remember, if you have a square like this, square, this diagonal will actually bisect this angle. This will be 2 equal size. For this one, you can just use a ruler, connect these two together. Oh, I think I need to label this one. Label the locus Y. Oh, I label this way, look nicer. Okay, now we go to the locus of point Z, equidistant from MN and O is the diagonal, it's actually the diagonal. Let me use another color, red color. Okay, so this is the locus of point Z. Locus of point Z. Mark the intersection symbol of the loci y and z with a symbol. Okay, use this symbol. So we need to find the intersection point between these two loci. So the answer will be here, and another one will be here. Okay, let's try this second question. The diagram shows a square PQRS. So this is square PQRS drawn on a grid of equal square with a side of 1 unit. Here 1 unit, 1 unit. This and this same length, 1 unit. X, Y, Z are 3 moving points in the diagram. So inside this diagram, inside this square, X is a point which move such that it is equidistant from the point Q and S. So this is Q and this is S. By using a ladder in the diagram, state the locus of X. Equidistant from two fixed points. If we have two fixed points here, A and B, equidistant from two fixed points means that you need to construct a perpendicular bisector. If we connect these two lines together, if we connect these 2 points together, this is not the locus. The locus over here. This is the locus for the point which move and is always equidistant from point A and point B. So this is a right angle and these two are equal length, perpendicular bisector. But in this part, we don't have to construct because we just need to state by using the ladder in the diagram, state the locus of X. One point is S is over here, another point Q is over here. So this will be the locus. So why? Let me explain a little bit. Since this is a square, right? This is a square. If this is a square, okay, same side, all the length same. So this is S, this is Q. We want the control perpendicular bisector of SQ, but because this is square, the diagonal here will be the perpendicular bisector of SQ. These two will be equal length. So this is one of the properties of a square. The answer for A, the line, or you want to say the straight line, or you can say PR, or you can say, you can change this straight line become the diagonal PR. Okay, so how about B? This one we need to construct. We need to draw. The locus of point Y, which moves such that it is constantly 3 units from the straight line TV. This is TV. Constant distance from a straight line. Okay, still remember, if you have straight line, constant distance from this straight line is a pair of parallel lines. The locus can go, it can be here or it can be here. Constant distance from a straight line. These two are parallel to each other. Okay, now we need to construct these two lines. Okay, let me erase this one first. So in this case, you don't have to use the compasses because you have the small grid here which will guide you how to draw it. Constantly 3 units, right? So 1, 2, 3 over here. Draw a straight line. So we just draw inside the diagram. Okay, so I try to draw it again. Make it nice. Okay, so just assume this is a straight line. Okay, a little bit, not really, not perfectly drawn this straight line. Okay, but this is a locus. We have another one, 3 centimeter, which is over here. Okay, so these two, remember when you draw a locus, label it. Label it. This two is a locus of point, locus of point y. Okay, let me double check again, correct now. 3 unit, okay, here 3 unit. How about the second part? The second part here, the locus of point z, which move such that it is constantly 5 units from B. Constant distance from fixed point will be a circle, but in this case, definitely we won't draw a circle because the point z only move inside the diagram. Outside, we don't have to draw it. Okay, adjust. 5 units from V, right? Okay, so place at V here. So start calculate 5 unit. 1, 2, 3, 4, 5. Okay, 5 unit. Let me use another color, green color. Okay. Oops. Outside you don't have to draw it. Let me erase it. Just draw inside and label it. Locus of point Z. Okay, last part. Mark with the symbol. Okay, use this symbol. The intersection of the loci of Y, the red color one, and Z, green color. Okay, so the intersection point is over here and here.